We all think adding a bigger model automatically makes CX cheaper and faster.
Actually, the savings come from targeted fine-tuning and routing low-confidence intents to a cheaper GPT-5 Nano.
So the cost isn't just the model price tag, but how we structure the fine-tuned pipeline.
Exactly. Once you factor compute, labeling, and version control, the ROI threshold becomes a precise ticket volume decision.
And if you're sitting in an enterprise architecture role right now, or you're a VP of customer experience, you've definitely seen these vendor pitch decks.
Oh, yeah. Every single day.
Right. And they claim that just throwing a massive, foundation model at your contact center is going to automatically print money.
Yeah, the assumption is always that raw capability just automatically equals efficiency. Like you just plug it in and costs plummet.
But the non-obvious reality here, and really the mission for our deep dive today, is that getting actual financial viability requires a tightly managed pipeline. You have to design a pipeline specifically to slash your output token usage.
Right, by like 35% compared to standard zero-shot prompting.
Exactly. And just to set the baseline, zero-shot prompting is when you just throw a query at the model cold, right? Like without highly tailored example.
Yeah, you're just hoping the model figures it out, but when you move away from that and actually fine-tune the model on your proprietary customer data, the math completely flips.
Which is what we're unpacking today. We're breaking down the exact operational thresholds, the hidden costs, and the critical architectural failure modes of fine-tuning GPT-5 for CX tasks.
And we're skipping all the vendor hype. We are looking directly at the API documentation today, because if you get this architecture wrong, you aren't just wasting API budget, you're actually breaking the customer experience.
Yeah, let's just get straight into the math, because vendors somehow always conveniently forget to put the hidden operational costs in those slide decks.
It's amazing how that happens, right?
Oh, total coincidence. But let's look at the compute reality of a GPT-5 fine-tune run.
Yeah.
If I pull up the docs for GPT-5.4 and look at a standard 10,000 example intent data set, the raw compute is incredibly cheap.
It's what, $120?
Yeah, literally $120. That's based on $2.50 per million input tokens and $15 per million output tokens.
Right.
So if I'm looking at that, I'm thinking, I can optimize an entire enterprise AI model for the cost of a nice dinner. It's a total no-brainer. So what am I missing?
You're missing the human element of data preparation. That is the hidden trap in almost every enterprise AI rollout right now.
Because the server is just doing the final step.
Exactly. That $120 is just the server spinning its wheels. Before that can happen, the model needs accurately labeled data, nuanced CX intents. And data labeling adds about 2 cents per individual example.
Which, 2 cents sounds like a rounding error.
It does sound microscopic, yeah. Until you aggregate it across enterprise-scale datasets and constant ongoing iterations. That 2 cents per example actually represents roughly 18% of your total fine-tune expense.
Wow, 18.
Yeah, and the reason it costs that much is because human annotators have to literally sit down and resolve ambiguous customer language.
Right, because humans type like a mess.
Exactly. A customer types, my bill is wrong and I want to cancel, but my router is also blinking red.
A human has to tag the primary intent so the AI learns what to prioritize.
And finance teams miss this, right?
Completely. This labeling line item is almost always missing from ROI models because finance tends to treat it as a sunk cost. They assume the data team is already on payroll, but it's a direct variable cost of the AI pipeline.
Right, so it's basically like buying this massive high-performance engine for a race car, but completely forgetting to budget for the specialized mechanic you need to actually calibrate the thing.
That is a perfect analogy, yeah. You have the horsepower, but without the precision tuning of the data labels, you're just burning expensive fuel.
But the documentation does show a silver lining here, doesn't it? It does. If you do account for that labeling tax and you structure the pipeline right, the payback threshold is surprisingly fast. Your total investment compute plus labeling is recovered after roughly 1,200 tickets.
Wait, hold on. Just 1,200 tickets?
Just 1,200.
Because an enterprise might process thousands of tickets in a single morning. You're saying the entire pipeline pays for itself before lunch?
Mathematically, yes, because each of those optimized tickets saves you roughly 10 cents compared to running the unoptimized zero-shot model.
And where does that 10-cent saving physically come from?
2 distinct improvements. First, the fine-tuned model needs way fewer human escalations because it actually gets your proprietary company jargon. Second, you see this massive 30% cut in false positive rates during intent detection.
Oh, so it stops miscategorizing a basic password reset as, like, a Tier 3 security breach.
Exactly. You are stripping out all that wasted operational motion.
Okay, but if the payback happens that quickly, why wouldn't an architecture team just run this fine-tuning pipeline constantly? I mean, customer behavior changes every week, right?
Right.
Like a telecom launches a new phone plan, and suddenly the chat logs look completely different. Intuitively, I'd want to retrain the model every few days to keep up with that data drift.
Intuitively, sure. But mathematically, that is exactly where mid-market teams bleed out their budget.
Really?
Yeah. The system requires what engineers call a stop rule to manage diminishing returns. Because the data drifts, teams often set up a monthly fine-tune refresh. But the hard data shows that after the second monthly iteration, the improvements just absolutely stall out.
Stalling out in what way? Like, how are we measuring the model quality here?
We use the BLEU score. It evaluates the quality of generated text against a human standard. And after that second monthly retraining, your BLEU score improvements hit a plateau of less than 0.5%.
Oh, wow. Less than 0.5%.
Yeah, because the model has already learned your core corporate grammar. Feeding it more variations of the same basic problems doesn't make it smarter. It just feeds it noise.
But you're still paying to process the data.
Worse than that.
Yeah.
Because you're processing expanded historical data sets with every single iteration, your compute costs are doubling.
So you're paying twice as much for a fraction of a percent of improvement.
Exactly.
That means the margins on this token math are incredibly tight.
Yeah.
Which tells me that making a mistake in this architecture doesn't just waste budget, it actively breaks the customer experience.
Oh, absolutely.
Let's actually dig into that operational reality, because the sources highlight 3 real documented failure modes where this exact mechanism goes spectacularly wrong.
Yeah. Let's look at the first major failure mode. This happens a lot in highly regulated environments like banking or insurance. It stems from the pipeline issues we just discussed.
Right.
It's a classic machine learning overfitting scenario. The architecture team wants absolute perfection in intent detection, so they train the model relentlessly on their historic intent labels.
They essentially build a model that perfectly memorizes yesterday's data.
Precisely. It becomes brilliant at recognizing the exact phrasing of yesterday's fraud attempts. But because its neural pathways are so deeply weighted toward those specific historical patterns, it gets rigid.
It loses its ability to generalize.
Yes. So when bad actors launch a novel, emerging fraud pattern using slightly different terminology, the overfit model completely misses it. The docs show this specific error leads to a 12% rise in false negatives.
So you built a perfect trap for mice, but the rats just walk right past it.
Yeah.
And in a regulated sector, a 12% spike in misfraud isn't just missing a service-level agreement. That exposes the enterprise to massive regulatory fines.
Exactly. But even if you avoid overfitting, you still have to physically route the customer's request to the right model variant. And this is where the GPT-5 Nano triage feature becomes a huge double-edged sword.
Right, because GPT-5 has an optimization routing feature specifically to cut costs.
Right. The intended mechanism is brilliant. It evaluates the complexity of a request, finds the low confidence or standardized intents, and routes them to the cheaper nano variant.
Which should theoretically cut your inference cost by up to 40%, right?
Right.
Without sacrificing accuracy on easy stuff like checking a balance.
Yes, but the misconfiguration happens when teams accidentally wrote the wrong tasks to Nano. Nano has a smaller context window, less processing depth.
It's like a triage nurse at a hospital. Nano is brilliant for triage, but if a misconfiguration sends an ICU patient like a highly complex, multi-turn summarization task to the triage desk, the whole system just breaks down.
And we know exactly what that looks like for the end user. Sending high-confidence, complex summarization requests to Nano results in physically truncated responses.
Just cuts off mid-sentence.
It literally stops before the thought is finished. The customer gets half an answer. The documentation tracked this, and it immediately spikes the customer effort score, the CES, by 0.4 points.
Well, yeah, because the customer has to call back to get the rest of their answer.
Exactly. Which means your 40% API saving is instantly wiped out by the labor cost of the repeat human contact.
That's brutal. But that routing problem gets even worse if your foundational data is skewed.
Right. Oh, exponentially worse. That's the third failure mode in the documentation.
Yeah.
A pure dataset bias rollback. A global enterprise fine-tuned their model, but their training dataset had this massive overrepresentation of U.S. English intents.
Oh, I see the domino effect here.
Mhm.
You flood the training data with U.S. English colloquialisms, so the model adjusts its internal vector space to prioritize those patterns.
Right. And when you deploy that globally, it physically loses its ability to parse regional dialects or non-English vernacular. The linguistic routing completely breaks down.
So what happened in this specific case?
Deploying that U.S. biased model caused a catastrophic 15% drop in CX customer satisfaction across the Latin American region.
A 15% drop.
Yeah. They were forced into an emergency manual rollback of the entire global model. They lost weeks of engineering time.
So we're looking at regulatory fines from overfitting, truncated responses from nano-misrouting, and massive CSAT drops from dataset bias.
It's a minefield.
It really is.
Huh.
To avoid these exact failure modes, architectural teams have to follow a strict operational sequence. It really comes down to establishing hard thresholds before a single token is ever processed.
Yes. And the most critical threshold to establish, and this is actually a highly controversial take in the industry right now, is the hard volume floor.
Yeah.
Do not fine-tune GPT-5 for CX intent detection unless your organization processes over 200,000 tickets per month.
Wait, 200,000? That is a massive volume requirement. If I'm running a mid-market support desk handling 80,000 tickets a month, you're telling me to just walk away from fine-tuning entirely.
I am telling you the math does not support it. Below that 200,000 ticket threshold, the amortized costs of the infrastructure, the labeling pipeline, the version control, the dedicated headcount, they completely outweigh the marginal gains you get in intent detection.
So what should they do instead?
For those smaller volumes, standard prompt engineering combined with RAG is the economically rational choice.
And for context, RAG is retrieval augmented generation. So instead of spending money to retrain the neural network on your policies, you just hook the AI up to a search engine. It fetches the relevant knowledge base articles and feeds them into the prompt in real time.
Exactly. RAG gives you the context without the compute overhead of fine-tuning, but there is one specific exception noted in the architectural docs here.
Which is?
If you are specifically building a summarization agent using the GPT 5.3 Insta model, that volume threshold drops to 150,000 tickets a month.
Okay, slightly lower. Why?
Because at that specific volume, fine-tuning yields a 22% improvement in ROUGE-L scores.
ROUGE-L being the metric that scores how well the AI's generated summary matches human-level comprehension, right?
Right. Getting a 22% jump there means the AI is suddenly grasping complex customer narratives it previously just fumbled. And crucially, it achieves that massive comprehension jump with only a 0.8% increase in latency.
Oh, so it stays fast enough for real-time chat.
Exactly, which financially justifies the pipeline at that slightly lower volume.
See, that is the exact level of architectural specificity enterprise leaders need, rather than the generic, fine-tune everything advice. But establishing a volume threshold assumes the underlying costs remain static.
Which they never do.
Right. Which brings up the second operational step. Yeah. Securing price caps from your vendor.
This is where architecture teams have to pull procurement and legal into the room. Because when you heavily fine-tune a model, you're inherently locking yourself into a single vendor's API ecosystem.
You can't just pick up your weights and leave.
Exactly. If you do not secure API price cap clauses in your contract, you are entirely exposed to unannounced pricing shifts.
I can easily imagine the disaster scenario here. You build this massive ROI model based on current token prices. Then 6 months later, the vendor rolls out GPT 5.5. They mandate an upgrade and quietly shift the pricing to, say, $5 per million input tokens and $30 per million output.
And without a price cap, your carefully calculated volume thresholds are invalidated overnight. The documentation outlines a specific scenario where an enterprise projected a $1.2 million saving, but it literally turned into a $300,000 loss over 6 months.
Just because the pricing changed.
But it's because the pricing changed and they couldn't migrate their fine-tuned weights to a cheaper competitor.
Wow. Okay, so step 1, check your volume threshold. Step 2, lock in the price caps. And step 3 is installing the circuit breaker we discussed earlier, right?
Right. Define the stop rule. Enforce a hard cap on monthly retraining iterations to prevent your compute costs from doubling for those negligible BLEU score gains.
But none of this happens without a clear chain of command.
Which is why the fourth and final operational requirement is establishing a strict RCI framework. The data clearly shows that deployments fail when responsibilities blur.
So who does what?
The data science lead executes the fine-tuning pipeline and manages labeling quality. The AI engineer deploys the model and configures the nano-routing logic so it doesn't truncate responses.
Right.
The CX operations manager defines the actual task requirements and success metrics. And the VP of customer experience is accountable for the ROI.
I have to pause and push back on that operational structure for a second.
Sure.
We are putting the CX ops manager in charge of defining success metrics. But the AI-specific metrics we've been discussing, intent, accuracy, ROUGE-L, BLU scores, they fundamentally clash with the legacy metrics contact centers have used for the last 20 years.
Oh, absolutely. That clash of metrics is the exact tension at the heart of this entire transition. It's not just a dashboard problem. It requires a structural redesign of how you run your operations.
So what actually changes on the floor?
First, you have to acknowledge the impact on headcount and team structure. Maintaining this pipeline isn't automated magic. Adopting this architecture requires a mandatory model versioning and data drift monitoring layer.
You need human beings watching the AI.
Exactly. You need staff monitoring whether the model is degrading or if the language vector space is shifting. Staffing this increases your CX operations technical headcount by roughly 10%.
And you're also looking at a massive shift in the skill mix. Like the days of frontline agents or floor managers making ad hoc tweaks to a prompt are over.
Because the pipeline is way too sensitive.
Exactly. So prompt engineering responsibilities migrate completely away from the front line and sit directly with the data science team.
Which brings us directly back to your point about the operational conflict with legacy metrics. For decades, CX centers have been governed by average handle time, or AHT. The goal has always been to get the customer off the phone as fast as possible. But consider the system we just designed. If your fine-tuned GPT-5 model and your nano-routing are successfully handling all the simple, high-volume intents automatically, what kind of tickets are left for the human agents?
Only the absolute hardest, most complex, most emotionally charged escalations.
Exactly. The AI handles the password resets. The human is left untangling a massive, multi-tiered billing dispute where the customer is already furious.
So what physically happens to your average handle time? It's going to spike dramatically, and mathematically has to.
Yes.
If an agent is spending 45 minutes resolving a single complex escalation instead of clearing 50 simple requests, their AHT goes through the roof.
And if your operational dashboards aren't recalibrated to account for that, your floor managers will start financially penalizing human agents for doing exactly what the AI architecture forced them to do. You must anticipate immense cultural pushback and attrition from your frontline staff if you don't realign your SLAs.
You have to measure resolution quality rather than pure speed. But that sounds incredibly disruptive. If we are increasing technical headcount by 10%, shifting critical skills away from the floor, and dealing with massive AHT spikes, where is the strategic payoff for the roadmap? Why even endure the friction?
The payoff comes from fundamentally shifting your agents into a tiered support structure that actually drives revenue. Handling those complex escalations requires heavily updating your training curricula, sure. But the data shows that deploying these fine-tuned summarization agents frees up agents to do deep problem solving.
And that impacts the bottom line.
It yields a measurable 0.5% lift in total customer lifetime value.
0.5% sounds sort of insignificant until you apply it to an enterprise user base.
Exactly. Scale that 0.5% lift across 1 million active users. That translates to about $5 million in incremental annual revenue.
Wow.
Yeah. That $5 million entirely offsets the amortization of the complex fine-tuning pipeline within just 4 months of deployment.
So the ROI isn't just in shaving pennies off API calls. It's in structurally elevating the value of the human interactions.
Precisely.
Look, if you are listening to this and you own an AI roadmap, we want to translate this architecture into immediate, practical takeaways. Based on everything we've unpacked, here are 3 concrete actions you should take this week.
Number 1. Audit your monthly ticket volume. You need to definitively answer if you cross that 200,000 ticket threshold for intent detection or the 150,000 threshold for summarization.
And if you are under that line, save your budget, halt the fine-tuning project, and stick to RAGI.
Exactly. Number 2. Check your ROI models. Open the spreadsheet and ensure that the 18% data labeling hidden tax is actively accounted for. If your model only shows raw compute costs, your projections are fictional.
And number 3. Meet with your procurement team. Verify that you have strict API price cap clauses locked into your vendor contracts before the next major foundational model drops. Do not leave your unit economics exposed.
Those are your marching orders.
But before we wrap this deep dive, we want to leave you with one final thought to mull over. We talked about the diagnostic muddy waters of legacy metrics. So ask yourself this. If your AI intent accuracy improves dramatically, but your traditional average handle time spikes because your human agents are only handling the absolute hardest escalations, which metric actually determines your customer experience success?
And if you want to understand how CRM and AI platforms actually work under the hood, not just what the marketing brochures claim, you need to subscribe to the CRM Position podcast. We break down complex topics like this without the hype, giving you the precise architectural reality.
It's the best way to stay ahead.
Exactly. Subscribe to the CRM Position podcast today so you can stay ahead of real architectural shifts rather than getting swept up in marketing narratives.
See you on the next deep dive.